Yeah, hi everybody. I hope you had a nice tea break. Groth. I'm a professor of data science at the University of Amsterdam. I do a lot of work on data provenance, also data integration, also getting data from unstructured sources, right? So things like natural language processing. And today I wanted to tell you a little bit about knowledge engineering in the language model era. So when I say the word language model, do you guys know what I'm talking about? Large language model. Some nods, a lot of blanks. How many people have played around with ChatGPT? Great. Okay, so you can play along with me. So we're gonna actually do some knowledge engineering right now. If you have ChatGPT, you can open it right now. We're gonna actually build a little bit of, let's say, the starting point of a taxonomy, just using ChatGPT. All right, so let's do some knowledge engineering. So I was interested in the ISKO conference and maybe building kind of a vocabulary of it. So I said, hey, what are the key topics of this conference, right? And it gives me all this disclaimer stuff, right? Whatever, right? So now we can get a list. So you can do this along with me. And it's gave me like 10 key topics. It's pretty good. So knowledge organization systems, and it gives me a definition. I even asked it to do it in like a list with bullet points. Information retrieval and access seems pretty appropriate. Semantic web and linked data. I saw some linked data today. Information architecture. We saw a very nice presentation about that. So that's a topic. Metadata standards, knowledge representation. All these seem like reasonable topics for this conference. Okay, great. So we starting to build this vocabulary of ISKO kind of automatically with ChatGPT. Obviously, it gives us all sorts of disclaimers about I'm a large language model, don't trust me. Okay, I don't trust it. It's a large language model. All right, so then I asked, okay, I need this in a proper computational form. So I said, hey, give me this as an ontology, in Turtle, in RDF. So if people are familiar with resource description framework, off you go. It tells me that information architecture is a concept. It gives me a namespace. It invented out of whole cloth. And actually a pretty good one, example.org. So that's what we tell students to use when they're making examples. It gives me RDFS labels for all of these concepts. So hey, we have this list, computational concepts. Then I asked it, and down here, more get out of jail free content, but also telling me why it chose those notions. So then I asked, well, let's build some relationships, right? So we want to go and build relationships between our concepts. So can you expand the ontology above to have relationships between concepts, right? Simple chat. And off it goes. So it gives me some SCOS. Who's a SCOS person in the room? SCOS people. Simple knowledge organization systems. So it says, let's see, information architecture is related to knowledge representation model. Kind of boring. Information retrieval access is broader than knowledge in AI. I don't know. But it's helping me build a knowledge organization system. And this took me, I don't know what, we did this in a couple of minutes, right? And this is something that has been really in the back of my mind now for about a year now, thinking about these large language models in our lab. Things like ChatGPT or the technology behind ChatGPT. What does that mean for knowledge engineering, right? So this is a really old knowledge engineering kind of text. This is like from the mid-90s. It's called Common CADS. It's a knowledge organization methodology. There are more modern knowledge organization methodologies. I like this one because it was people in the Netherlands liked it, but it's also kind of like really when knowledge organization was really, really popular, it was a thing. And I've been looking at these methodologies and thinking about, okay, how do I revisit these knowledge engineering methodologies with this kind of new kinds of technologies? And so that's the kind of thing I'm going to bring you through in this talk, right? So should we revisit knowledge engineering? How should we go about knowledge engineering if you're going to build a taxonomy, a knowledge graph, a vocabulary today? So my first motivation about this was building knowledge graphs. Who knows what knowledge graphs are in the room? Most, everybody knows what knowledge graphs are. Great. So knowledge graphs are these large scale structured graph databases, usually with some sort of smaller schema, maybe comprehensive schema, but tons and tons of facts. They're key elements to many AI systems, Google, Facebook, eBay, big pharma. I get asked to build lots of knowledge graphs a lot. I help build knowledge graphs. And one of the problems I've always had is people ask me to build a knowledge graph. And I'm like, okay, I have some ideas about how to do that. But actually, what would be the methodology for building a knowledge graph? What would the knowledge graph development cycle look like? And so this is a question I had, and we started looking at that. We started reviewing the literature. And so this is how you build a knowledge graph, right? You start with some data collection, you do some data modeling, you do event annotation, you do entity annotations. So that's how you build a knowledge graph, but that's also how you build a knowledge graph, right? So here you propose systematic procedure for building a knowledge graph. You do some visit level data, you do some data preparation, some entity recognition. We saw that in the last talk. You do some graph embedding. Oh, this is also how you build a knowledge graph, right? And this is also how you build a knowledge graph. And this is also how you build a knowledge graph, right? So we were thinking about, well, how do you build a knowledge graph? And so we did this systematic literature review, looking at this, another way to build a knowledge graph. And what we tried to do is synthesize the key steps in going about actually constructing a knowledge graph, because I have people coming to me, I want to build a knowledge graph, and I just don't want it to be my knowledge. I want it to be synthesis of the knowledge we have in the literature. And so what we did was we did this review, this systematic review, looked at essentially ever since Google kind of coined this term knowledge graph onwards, looking at all the papers that say we go about building knowledge graphs. And my favorite part of this actual paper is, if you go to it in the end, I have clippings of all like 50 of these figures, these little workflow figures I'm showing you. That's all in the appendix of the paper. So if you want lots of workflowy looking diagrams, it's all there. And so this is what we came up with, right? This is a synthesis of the major steps in building a knowledge graph if you look at the literature. I'm not saying that it's exactly what it takes. I'm just saying that if you read the literature, this is what we came up with. So you identify some data. Knowledge engineering people here, we need to construct the ontology for that, right? We extract some knowledge, whether it's from a database or doing some information extraction. We extract the key entities, we extract the key relations, we extract attributes of those entities. We go about and we process that knowledge, we integrate that knowledge, we map it to our ontology, and then we try to complete it with all sorts of algorithms. Then you have actually having the knowledge graph, storing it maybe in a graph database, maybe not, displaying that knowledge graph in some search system, helping people use it. We may evaluate the knowledge graph itself, and then you should update the knowledge graph and you go around in a circle. It's kind of seems pretty logical, pretty reasonable way to do it, pretty good guide, but at least I'm not making it up, right? That's what the literature says. One of the things that really bothered me about reading the literature, though, is this little line. This line, update the knowledge graph. There's like one paper that describes it. Almost every paper we looked at building a knowledge graph and then stopping, right? Which is very funny, right? Because we all know that's not true, right? You build this knowledge graph and you actually need to update it. So this is a paper we wrote a long time ago now about thinking about changes, right? So changes in knowledge organization systems, knowledge graphs, all the different kinds of change you need to deal with, ranging from changes in political influence, to changes in the software used for extraction, to changes in the other underlying literature that maybe you're using to build a knowledge graph. So we're thinking about this this is a work we did last year, thinking about, hey, I want a better systematic way, a new way of doing knowledge graph, knowledge engineering with these knowledge graphs in mind. We ran a workshop at Dagstuhl, which is a week-long thing, thinking about knowledge graphs and knowledge engineering as it stands now. So if we go back, how will we change what we teach? How will we change our literature about how to build these systems? Lots of cool people there. And so this is the real change in knowledge engineering, right? So knowledge engineering before, gathering highly curated knowledge from experts, encoding it into knowledge bases, mostly manual processes focus on how knowledge is structured and organized rather than the data itself. Often used in expert systems, search systems, and kind of expensive to produce, right? No, can you guys see that slide? I think so. You look at our literature over time, what we see is a change in what we have to do with knowledge engineering. So if you go all the way back to 1929, you think about knowledge as true beliefs that come from some sort of reliable process, right? So that's kind of Ramsey's definition of knowledge. And what you see is over time, this buildup of different requirements for actual knowledge. So in Feigenbaum, so in 1979, talking about actually knowledge is pretty domain specific. It's hard to have knowledge of the whole world, to things like the open web, so linked data, that maybe we should integrate knowledge from different places and link together, to newer ideas of, okay, we need to have less schemas and allow our knowledge to actually update over time, or to where we are now. So I call these, Brad Allen calls these different eras of knowledge. So kind of the dawn of AI and expert systems, to the AI winter, to the semantic web era, to what I would call now the language model era. We're talking about systems where we can automatically learn lots of knowledge just by reading the web. So your ChatGPTs. So this is the kind of era we're in now. So if we look at knowledge engineering today, we're thinking about automated processes with human in the loop, large knowledge bases, large knowledge graphs with heterogeneous data. We're using machine learning, you're using crowdsourcing, you're using all these multiple change sources to build your knowledge. We're using off-the-shelf data and off-the-shelf AI capabilities to actually make the cost of knowledge acquisition pretty cheap. And you have lots of adoption of these knowledge graphs. So my assumption that I started off with was this, I walked you through this pipeline of building knowledge graphs, that in some sense what we need is this kind of updated theory of knowledge engineering that looks at the combination of large language models and knowledge graphs together. And we would need a new software engineering methodology that copes with all these things, right? This was my idea. I need a new theory. I can write a lot of papers about it. It'll be cool, right? It'll be neat. And then I said, well, maybe I'm wrong. Maybe we actually don't need a new theory of knowledge engineering at all. Maybe the old theory of knowledge engineering actually works. Could be, right? So this is Common CADS. So Common CADS is this from the 90s knowledge engineering theory. A lot of newer ones are based on it. So an interesting thing about Common CADS, it has some key principles. One, that we're trying to model human knowledge. We're operating at a knowledge level, the classic knowledge level, not about specific things. Knowledge has some stable internal structure that is distinguishable by specific types. And we can manage learning in kind of a controlled spiral way. Now, the interesting thing is you produce these artifacts, right? These design models, these documents. You have some sort of knowledge model, right? This is a lot of what we think about when we think about knowledge engineering, things like ontologies. But Common Cats also has these other models where they talk about organizations. What's your organizational context? What's the task you're trying to achieve with the knowledge you're trying to build? Who is involved in your knowledge? So the interesting thing here is if you look at Common Cats, less is really about the ontology or vocabulary we're trying to build. A lot of it is actually about the social embedding and the human related notions that you do when you build a knowledge system. This is kind of exciting for this conference because we're talking about people right here. And essentially, if you think about knowledge engineering, really a lot of it is not about this knowledge. That's our outcome, but instead it's about the context, the gathering of information from people designing systems. Okay, so that's Common Cats. That's knowledge engineering in very short. So now I'm going to talk to you about large language models and how we actually work with them in practice. So there's this notion of prompting as programming. So you might ask me, what's prompting? You guys just did prompting. We did prompting together, right? We asked ChatGPT, hey, give me a list of all the topics. That's prompting. So in fact, in prompting, what you do is you just actually give English language prompts and ask for answers. So for example, if you're doing a sentiment analysis task, you just say some input and then you have a template. The movie is, then the language model will create, it's great or bad. If we're doing the task of named entity recognition, which you saw, you can just prompt the model, right? You do blank blank is what kind of entity? You're just asking it a question. This is actually how you can do programming with one of these, with ChatGPT or any other large language model. What you can do is combine these prompts, these questions, together in chains, right? So here's an example of a library that lets you do that. So I can ask, okay, what are the key topics at ISKO? Can you provide me the people involved, right? So I can ask these questions iteratively. I can chain those two together. And so I'm programming, I'm creating workflows to build my knowledge. I'm programming with natural language. So the interesting thing here is you can also combine existing programmatic systems. So here's an example. I can prompt and then I can include calls out to other programs. So here, for example, this one, I can have like a little calculator that actually does some calculation. And just in my prompt, I can actually put that calculator, and you have systems that are able to call out to actual programs. Or if you're introduced in machine translation, you have a specialized machine translation system, you can actually have little programs that you call out to. And this is how you actually include it. So we're literally programming here. I could say the name derives from, I don't know Spanish, the Spanish word for machine translation, turtle. And you just put that in the system and it will output it for you. Or I can even include search things. And I'm just programming away by writing natural language sentences. And this idea of combining our existing knowledge with existing programmatic knowledge, our existing taxonomic knowledge, our existing knowledge graph knowledge with natural language is very actually very important and very hot right now as a way to do these things. This is an example of ChatGPT combining with something called Wolfram Alpha, which is a programmatic system that lets you do all these kinds of calculations. If you look at what Microsoft does with their architecture, what's interesting here is they have Copilot, right, which is essentially GPT-4. And one of the first things they do is they use their background graph. So if you don't know this, in Teams, they build up a knowledge graph of every person and topic that you're talking about in Teams, your meetings, and your calendars. And they use that background knowledge to actually constrain how this Copilot works. So when we're doing this prompting, we're kind of constrained to the data coming from your own system, right? So this combination of background knowledge about your organization, background knowledge about your theme with the large language model. And so we're developing kind of new architectures for thinking about how to actually build these knowledge-oriented systems. You start off with some schema, but the way we program this is through a combination of prompt templates, so these questions that I showed you before, with existing knowledge that I may have in a taxonomy and a knowledge graph. And what I'm doing is building up these prompts, giving it to my large language model, and then building increasing the size of my knowledge graph that way. Right? These are the kinds of architectures that we're starting to think about with respect to knowledge engineering. So back to knowledge engineering methodologies, the relevance of context. So actually what we see here is context is important in these things. This embedding in my organization, right? Not just using ChatGPT, but using Microsoft or whatever your organization's language model is bound to the information about your organization. What is the task? Who needs to get it done? So when I'm talking about these kinds of architectures, an important goal is, what am I doing this for? What is the task? Who has the authority to actually do this task? Which agents do I rely on? Do I rely on the large language model? Do I rely on people to do it? So this is context in Common Cats. Concept. So how do I wire together? They talk about communication in Common Cats. This is really about wiring together different prompts. So I already showed you about that one. Knowledge model, this we'll get to in a second. And artifacts. You need documentation of all of this stuff. Even if I'm using a large language model, I need to know what prompts you've done. I need to know how you built that system. Right? So if we look at all the things from Common Cats, all the things from knowledge engineering, a majority of them still apply to building these systems. Now let's talk about the knowledge model. So typically, when we think about knowledge in this space, we think a lot about symbolic representations and languages or formalisms, right? So I want to express my taxonomy in some formalism, or I want to express it in RDF. We're interested in creating concept schemes, right? Or hierarchies or thesauri. That's what we're interested in. That's what we consider a knowledge model. So an interesting contention I have is that large language models actually allow us to encode a lot of our knowledge using just natural language. So we're going to express the concept in definitions to drive our applications just in natural language. And the definitions for our applications becomes one agreement within an organizational concept. So that thing we start with, oftentimes when you're building an ontology, where you get the definitions, you get everybody into a room, you try to figure out, okay, what do we mean? Actually, that's the work of knowledge engineering. All this encoding it into fancy formalisms, maybe not so important. So this is all conjecture, this is all an idea. What we're trying to do is figure out this future. So how do we like to use knowledge engineering methodologies to design these large language models applications? We're interested in actually mapping prompting, what I was doing when I was building that vocabulary up, to knowledge engineering methodologies. What kinds of knowledge engineering can you accomplish just with large language models? We have a hackathon in 2 weeks, actually, where we're going to try to do this. We're going to do knowledge engineering just with lots of different LLMs. And I really think this is kind of the more interesting place we're going. How do we think about the engineering of AI applications, especially knowledge-enabled AI applications? And this is some work that. How much time do I have?
What's left to do the whole thing?
Oh, with questions or more time?
No, sorry, you've got 15 minutes left. I can't.
Okay, I have time. Going fast. We have lots of time for
5 minutes for slides.
Okay, great. We're almost there. So this is how you engineer or how to design these AI applications, thinking about what's the combination of, for example, symbolic knowledge with machine learning knowledge together to build architectures. And this is really kind of more broadly something that's really happening in a lot of different modern software development around AI. It's kind of what is the right combination between these generative language models where you're doing prompting, what specific data do you need in your application, and how do you wire all those together? So to wrap up here, so my claim is that with large language models, right, application construction is about what you do. It's fundamentally about knowledge engineering, because anybody can program, because you can just prompt these language models. And then the question is, how do you put those prompts together, these English language prompts together to build your application? The experience you have as library information science professionals or people who know how to do these methodologies is actually even more important, because getting information about your context is now the central thing, right? Knowing how to wire these applications together, knowing how to talk to people, understanding the organizational context, understanding the communication that people want to achieve, figuring out consensus about concepts and terminology, all of those become really important. And actually, you can get to your applications faster that way. I think we have an opportunity to update all of knowledge engineering methodologies through this lens of prompt programming, right? So we can take what we know about knowledge engineering and actually update it, but with this natural language interfaces there. And I think, like, for this, fairly tiny conference, right? But I think you guys have the knowledge that's really needed currently, right? So there's a lot of people kind of grasping in the dark. How do I build consensus about these things? How do I know what's important? How do I actually get agreement with my stakeholders, right? All of those skills are really in demand, and this community, I think, knows about those, right? So there's a real opportunity to, inform that world, this kind of massively upcoming world, with the kinds of knowledge that's in this community. So with that, I think I have plenty of time for questions.